Hello everyone. So today we're going to cover some basic terminology which you should know in order to better understand the second derivative test, which we'll cover in a later video. So as always, if you feel like you already concretely understand this concept, feel free to just look at this diagram, for this basically holds all the information you'll need to know from this particular video. Okay, so you may have noticed that some functions tend to be rather curvy. Well, that's because they have something called concavity. Now, concavity is based upon the sign of the second derivative. So for example, to be concave up is to have the second derivative be greater than 0, or positive. This essentially means that the graph, or the function, looks like a parabola, wherever it's concave up, open upwards. In other words, it more intuitively looks like this. So to be concave down means the second derivative is less than 0, or it looks like a parabola open downwards, wherever it's concave down. Now, between concave up and concave down, there's something called a point of inflection. Now, a point of inflection is where the concavity, or the second derivative, is 0, and the concavity changes sign. For example, this graph goes from concave up to concave down. Therefore, between them, there's a point of inflection. However, note that if this were to go concave up to concave up, or if the second derivative was positive, then 0, then positive again, then there would be no point of inflection. So, in order for it to be a point of inflection, the second derivative must change sign. Just because it's 0 doesn't make it a point of inflection, and this becomes a major concept in most tests. So thank you guys. To briefly overview, concavity is dependent upon the second derivative sign. So to be concave up means to look like a parabola open upwards, and the second derivative is positive. To be concave down, the second derivative is negative. Points of inflection happen only between changes in the second derivative, and where the second derivative is equal to 0. So thank you guys. As always, hope you have a wonderful day in calculus.